Okay, we're going to look at the homework problem that asked you to compare the graphs of a power function and an exponential function. So you had something like x to the 8th or x to the 10th or something like that, and you were to compare it to e to the x. Now, when you start with a power function, it's going to start by being much bigger than e to the x at the very beginning. Well, they're going to cross twice. That was a bad graph. I'm going to start this over. Actually, I'm not. The whole point was that this is really hard to show you with a hand-drawn graph. And so technology is going to make this a lot easier. So I'm going to show you two ways to do it with technology. I'm going to start by using Desmos, and then after I do Desmos, I'll show you on a graphing calculator. So if you prefer the graphing calculator, just skip ahead in the video to that part, and if you prefer Desmos, you can stop after I do the Desmos demonstration. So let's start with Desmos. So this is free online software that you can get. And just get Desmos. And you can graph functions and you can do other things, and it's the other things that I want to show you how to do that can help you with this. So let's put in the two functions. So I've got f of x equals e to the x. So there's one. And then our other one, let's do g of x. Actually, I think in your homework they had this one was, let me see what it was. Hold on, let me just pause the recording. So it was f of x is x to the 8th or 10th or something, and g of x is e to the x. And the question is, when does g finally overtake f? Just to make this so it's not anyone's exact homework, let me change this to x to the 5th. No, let me, yeah, x to the 11th, how about? There we go. Okay. I think they did all even, x to the 12th. Okay. Alright, so now, if I zoom in real close, so I get very close, I can see where they intersect the first time right here. And where they intersect the first time, notice this is when when x to the 12th becomes bigger than e to the x. And that will happen just a little bit more than 1. But that's not what they're asking. They're asking, when does g of x get bigger than f of x? And so you think, okay, well, it's going to happen sometime. And so you zoom in or out, you zoom out and zoom out. So, how can you tell? You know, it's like it's really hard to see. So let's get an idea as to where it is. So let's look at a table of values. In this table, let's put in x. Let's just start by guessing. We'll put in 10, 20, 30, and I put in 1. And y1, let's have that be f of x. And then I tab over, and I'll put in g of x. And I want to link this to this one. Actually, what I wanted to do is I wanted to take the 1 off of this x. So this had a little 1 on it. I deleted that, and now I have my correct numbers here. So when I started the table, it was x sub 1. So I took the 1 off, and now I've got the numbers. Okay, so now I can see when x is 1, f of x is 1, and g of x is the value of e 2.71. Okay, so now let's look at 10. F of x is 1 times 10 to the 12th, and g of x is still smaller than that by a lot. Okay, and now when we get to our next value of x, which is 20, f of x is, which is x to the 12th, is something times 10 to the 15, and e of x is times 10 to the 8th, and then I get to 30, f of x is 10 to the 17th, g of x is 10 to the 13th, still not bigger. Let's try 40. And now for 40, f of x is times 10 to the 19, g of x is 10 to the 17, still not bigger. Let's try 50. And now f of x is 10 to the 20, and g of x is 10 to the 21. So I see that g of x is finally bigger than f of x. So now let me change my viewing window. Notice how big these function values are. Those are our y values. So I'll change my viewing window, and I'm going to change x to go from 0 to 50, because I know it happens between 40 and 50, so I can just change it to be 40 to 50. And now let's look at our y values. We're at 10 to the 20 and 10 to the 21, so I'm just going to go to the 20 and 10 to the 22. Is that going to work? Let's see. It's too hard to tell there. I think I need to get it a little bit smaller. Let's see. Let's zoom in on our table. Let's try 47. And we have 10 to the 20 for f of x, and 10 to the 20, so 47. So that's around 10 to the 20. So 1 times 10 to the 20, 2 times 10 to the 20. Alright, so I'm going to change, leave my x values there, but I'll have my y values go from 10 to the 20 to 3, 10 to the 21. Will that work? I think that works. Yeah, that definitely works. Okay, so we can see that the exponential function finally takes over the power function here, and if I just go right there, I can see that happens at 45.9238. So you would do that with whichever functions you have. Okay, so now I'm going to do the same thing with the graphing calculator. So if you just wanted to see how to do Desmos, you're done. If you want to stay and view it on the graphing calculator, you can. Alright, so here is a TI-84. If you're interested in learning how to do it on an Inspire or on a different kind of calculator, let me know. So first thing we're going to do is we're going to put in our two functions. We're going to have x, and I'm going to do x to the 12th. Oh, that's interesting. Okay, so x raised to the 12th, and y1 and y2, I'll have e to the x and that's the e, that is the second function of the natural log function. And if I just do a standard viewing window, zoom 6, I'm not going to see anything. Well, okay, I take it back. I do. I see the first intersection point. So what I see is the point where the oh no, it did it for me. Wow. Okay, so this is nice. So it went ahead and zoomed to fit for me. I'm not sure. I want to check something. Let me see. Hold on. Oh, no it didn't. Sorry. It shows where this point right here, this intersection point, is where the power function gets bigger than the exponential function. The exponential function gets bigger than the power function somewhere much further on. If we find this intersection point, that's not the point we're looking for. So this intersection point is where the power function gets bigger than the exponential function, but we want the other one. Okay, so we don't want this one that happens a little bit bigger than 1. We want the other one. Well, we could try zooming out. But that doesn't look so nice, and it doesn't really get us anywhere anyway. So let's do a table of values instead. So go to second table set and change independent to ask so that you can put in your own numbers, and then go to second table, and then for x we'll put in 1, and we want to see y1 and y2. y2 is our exponential function, y1 is our power function. So now let's put in 10. We see at 10, y1 is much bigger than y2. We want to find out when does y2 get bigger than y1. So I can try 20, and this one's 10 to the 15, 10 to the 8th. No. I can try 30. No. 40. No. This is 10 to the 19th. That's 10 to the 17th. I can try 50. 50, this is 10 to the 20th, this is 10 to the 21st. Okay, so now y2 is bigger than y1, and I know it happens somewhere between 40 and 50. I can try 45. At 45, y1 is still bigger. And notice our number is right around 10 to the 20. So let's go to our window. Not second window, just window. And I want my x-min, I'll have it be 0. Well, let's have it be 40. X-min will be 40, and x-max will be 50. And we'll leave the x-scale 1. That's fine. Y-min, let's have it be 10 raised to the 20 power. And y max will be 10 raised to the 21 power, and we'll have x scale be 10 to the 19, and let's graph this. Okay, so I don't have my y value on the screen. I wonder why. Let's see, window. Let's have our y-min be 1 times 10 to the 19. There we go, and now we can see it. So now I can find my point of intersection. I'll go to number 5, intersect first curve, second curve, guess, and there it is. So it's at 45, and our y is 8.7 times 10 to the 19. Oh, well, that's why I didn't show it, because I had it too small. All right.